Welcome to this video. Today we will learn about tangent to a circle. Can you recognize these shapes? Identify them by pausing the video. Now match your answers. This is a triangle. This is a parallelogram. This is a rectangle, square, kite, rhombus, pentagon, and this is a circle. In your previous class, we learned about all these shapes thoroughly. But today, we will discuss briefly on circles. Can you tell me, what is a circle? We learned in the previous class that circle is a collection of all points which are at a constant distance from a fixed point in a plane. The fixed point is called the center of the circle and the fixed distance is called the radius of the circle. If we increase the length of this radius to the left, then we get a line which intersects the circle at 2 points and passes through the center. Such a line in a circle is called the diameter of the circle. Also, in our last class, we learned about chord of a circle, segment of a circle, arc of a circle, and sector of a circle. What can you see in this figure? Absolutely right. In this figure, we see a boy playing with 2 sticks and a wheel. If we represent the wheel by a circle, the wheel marks and the sticks by lines, then we get a figure like this. Observe this figure. What can you say about the circles and the lines here? There are 3 possibilities of the arrangements of circle and lines. In the first case, the line, say PQ, does not coincide with the circle at any point. In this case, line PQ is a non-intersecting line with respect to the circle. In the second case, a line, say RS, intersects the circle at 2 points, that is M and N. In such case, we call the line RS secant of the circle. In the third case, the line, say UV, intersects the circle at only 1 point. In this case, UV is called the tangent of the circle and the point common to the line and the circle is called the point of contact. Hence, we can say that the line which intersects the circle at only 1 point is known as the tangent to a circle. Can you draw any other line on this circle passing through the point M? Let's give it a try. From the point M, let's draw some lines on the circle. You can see that all the lines intersect the circle at a point other than point M. So all these lines are the secant lines of the circle. But the line PQ intersects the circle at only 1 point M. It is the tangent of the circle at point M. So, from this activity, we can conclude that there can be only one tangent passing through a point of a circle. Also, if you look here, you can observe that on bringing all other lines except PQ to the position of PQ, the common point of the respective line and the circle gradually comes closer to the common point M and ultimately it coincides with the point M. With this, we get to know that the tangent to a circle is a special case of the secant when the two endpoints of its corresponding chord coincide. Can you tell me how many tangents can a circle have? Think about this question. We will discuss it in our next video. Today in this video, we learned the line that intersects the circle at only one point is called a tangent to a circle. The common point of the circle and the tangent is called the point of contact. At a point, there is only one tangent to the circle. The tangent to a circle is a special case of the secant when the two endpoints of its corresponding chord coincide. In the next video, we will learn about some more interesting facts related to tangents. Tangent to a circle. Welcome to this video. In our previous video, we learned about tangents and some interesting facts related to it. Today, in this video, we will get to know more about tangents to a circle. In our previous video, we left this question unsolved for you to try. So before moving ahead, let us discuss this question. You must remember that there is only one tangent at a point of the circle. And circle is a collection of infinite points. Hence, there can be infinite tangents to a circle. In our previous video, we learned that the tangent to a circle is a special case of the secant where the two endpoints of its corresponding chord coincide. Let us look at this activity to understand this better. First, let's draw a circle and a secant MN of a circle. Now, if various lines are drawn parallel to this secant on both the sides, you will find that after some steps, as we are reaching towards the circumference of the circle, the length of the chord formed by the lines will gradually decrease, which means that the intersecting points of line and circle are coming closer. In case 1 and 2 of secant, the distance between the points becomes 0, which means that both the points coincide. On observing, you will find that in this situation, line 1 and 2 are two tangents parallel to the secant MN. With the help of this activity, we can say that the tangent is a special case of secant where both the ends of the corresponding chord coincide. Let us see another activity. Draw a circle and its tangent on a piece of paper. Now, if from the center O of the circle, some lines to the tangent are drawn, which are OA, OB, OC, OD, OE, OF, OG, and OH. On measuring these, we find that the line OD is the radius of the circle. Its length is the shortest of all. Also, if we measure the angle between the tangent MN and the line OD, you will find that it is right-angled. That is, line OD is perpendicular to tangent MN. Based on this activity, we can say that the tangent at any point of a circle is perpendicular to the radius through the point of contact. You can confirm this yourself by any other method. Today, in this video, we saw the relationship between the radius of a circle and its tangent. In the next video, we will see some more examples of tangent. Welcome to this video. In the previous video, we studied the relationship between the radius of a circle and its tangent. Today, in this video, we will see an example based on this. The radius of a given circle is 7 centimeters. Point P is located on the circumference of the circle where the tangent to the circle is drawn. If a line is drawn from the center O of the circle, it intersects the tangent line at point Q in this way. If PQ is equal to 24 centimeters, what will be the length of OQ? Pause the video to solve the question and then match your answer. We know that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So, OP will be perpendicular to PQ. Can you tell what to do next? Absolutely right. We can use Pythagoras theorem in the triangle OPQ, from which we get square of OQ equal to square of OP plus square of PQ. On substituting and solving, we get OQ equals to 25 centimeters. Let us have a look at another example. The tangent at a point C of the circle and the extended diameter AB of the circle intersect each other at point P. If the measure of angle PCA is 110 degrees, find the measure of angle CBA. Pause the video to solve the question and then match your answer. Let's first draw a figure for this question. Suppose there is a circle with center O and diameter AB. On extending AB, it intersects the tangent formed at point C on the point P. From the question, we know that the value of angle PCA is 110 degrees and we have to find the value of angle CBA. Let us join point C to the center O. Now, you can see here that OC and CP are the radius and tangent of the circle at point C respectively. Thus, angle PCO will be right-angled, with the help of which we can find the value of angle OCA. Now, in triangle OCA, the sides OA and OC are equal being the radii of the circle. So, angle OAC and angle OCA will also be equal. We know that the sum of the three angles of a triangle is 180 degrees. Which gives us the angle AOC equal to 140 degrees. Also, the angles AOC and angle COB form a linear pair. So, the angle COB will be equal to 40 degrees. Now, we can see in triangle OCB that the sides OB and OC are equal being the radii of the circle, due to which the opposite angles are also equal. The sum of all the angles of a triangle is 180 degrees. Due to which angle CBO equals to 70 degrees, which we can also write as angle CBA. Today we saw some examples based on a circle and its tangents.